Our bioproduction customers tell us efficiency, safety, and compliance are high priorities. Our Optima line and Avanti jigs and centrifuges help our customers do exactly this. If you are producing vaccines, for example, and need to adhere to good manufacturing or good laboratory practices, efficient workflows need to be matched with compliance. Data management is part of this, of course, when separating or isolating biological materials for production. With the Windows-based interface and data tracking capabilities, it's easy to manage the data on your centrifuge runs. Real run graphing lets you plot speed and temperature over time to track and report your progress. You can track and control usage with user-defined profiles and electronic signatures, and track rotor usage by serial number. With the Avanti JXN centrifuge, we can get rid of those logbooks. It's easy to store your data on the instrument, export to a network, load onto USB, or even print it out. The Avantis can also be easily networked to other instruments and your laboratory data system. The Avanti JXN and the Optima XPN have a wide rotor library with capacities ranging from 6 liters to 30 milliliters to address every point of your workflow. I also want to make sure to mention the optional pharmaceutical-grade sterilizing filter system. It is a great feature in bioproduction facilities. Plus, it's also very easy to change. Find out how the Optima and the Avanti JXN centrifuges can support your bioproduction needs.
Acoustic droplet ejection, or ADE, uses sound energy to move ultra-low volume droplets of liquid from a source location to an inverted destination with extremely high precision and accuracy. Ecosystems move droplets of 2.5 nanoliters per ejection. To transfer larger volumes of liquid, multiple droplets are ejected from the source at up to 500 times per second. The LabSite Echo 500 series liquid handlers use ADE to transfer liquids from 384 or 1536 well microplates into 96, 384, 1536, and 3456 well destination plates, appropriate for your experimental needs. The ecosystem presents a source plate gripper, and robotically or manually, a filled source plate is placed upon the extended platform. The extended gripper pulls the plate into the ecosystem, where it is deionized to ensure straight flight of the droplets. The destination gripper is extended and inverted to hold a destination plate. The destination plate is flipped and pulled into the ecosystem. Surface tension will keep fluids in the wells of an inverted destination plate. Flowing water couples the transducer to the source plate. The transducer is positioned beneath a well and emits a soft ping of energy. Energy is reflected from each of the 3 interfaces: the bottom of the plate, the bottom of the well, and the meniscus of the fluid in the well. The ecosystem uses the amplitude of the reflected sound to calculate the level of hydration of DMSO if this solvent is used in the source, and the delay of the final reflection to calculate the depth of the fluid in the well. A well filled to a greater depth requires a longer time for the reflection to return from the surface. The fluid in each well is analyzed, as shown here in slow motion. The information provided by the survey determines that the proper ejection parameters and transducer positioning are used to ensure accurate and precise nanoliter transfers. The actual total analysis time for a 384 well plate is less than 26 seconds. Once the wells have been surveyed, the transducer returns to the first well, focuses the acoustic energy where the survey determined the meniscus to be, and emits a stronger ping of energy. The energy causes a 2.5 nanoliter droplet to eject from the surface and to fly up into the appropriate well of the destination plate above it. Surface tension captures and holds the droplet in the well. Fluid from the same source well can be ejected into another well of the destination plate. More droplets are ejected to increase the volume. Ecosystems can transfer to dry or pre-filled destination wells. A record of empty source wells is kept to help eliminate false negatives. Ecosystems can transfer 5 nanoliters from each well of a 384 well plate to a corresponding destination plate in less than 37 seconds. Cycle time can be less than 95 seconds. When the transfer is complete, the destination plate is extended and inverted to allow another plate to enter the system. Ecosystems can upstack or downstack to plates of higher or lower density. Source plates are easily changed to move from low-density plates into high-density formats. The ecosystems use precise and accurate ADE technology to transfer nanoliter volumes of fluids with no tips or nozzles, saving you hundreds of thousands of dollars annually. Eliminating surfaces that can touch the transferred fluids also prevents cross-contamination and losses to surface absorption to ensure more sensitive and accurate detection of your best hits. The Eco 500 series liquid handlers are the choice for ultra-low volume liquid transfers.
Is your ELISA not working as desired? What seems to be the problem? Getting your ELISA to work is a tricky process. This is because there are several steps where potential problems can occur. In this video, we'll discuss how automation using BioMech I-Series liquid handlers can help overcome the problems associated with ELISA. Here are some of the commonly seen problems in ELISA: weak or no signal, saturated signal, poor standard curve, slow color development, poor replication, and contamination. Weak or no signal could be a result of an omission of a key reagent or a step. Therefore, adding all the reagents in the right order is crucial for a successful ELISA. When you're pipetting many samples manually, a slight change of focus could lead to missing a well or a column of wells, resulting in missing signal. By using a liquid handler, you can overcome these sources of variability. The BioMech software lets you build your ELISA method using existing steps, making it easy to write your method. You start your method using the app-style BioMech method launcher. Then, Guided Labware Setup provides specific text and graphical setup instructions with reagent volume calculations and step-by-step instructions to prepare reagents. Once you place your samples, reagents, and labware on the deck, Deck Optics Final Check analyzes the deck for common setup errors and alerts you prior to the start of a run, lowering the anxiety of novice users and providing peace of mind for the pros. Wash steps are repeated between each step of ELISA to remove unbound material. Inadequate washing creates a saturated signal resulting from nonspecific binding. Manual washing is time-consuming and cumbersome. Fortunately, BioMech liquid handlers comes with a large volume multi-channel head with the capability to wash 96 or 384 samples at one time. In addition, plate washers can be readily integrated to the BioMech for high-throughput applications. ELISA quantification is based on extrapolating a standard curve. A poor standard curve can jeopardize your equipment and samples. One way to improve the standard curve is the accurate pipetting of standards. BioMech software offers versatile pipetting control through pipetting templates to fine-tune the pipetting based on the reagent and labware so that you pipette out every last drop. The BioMech Span 8 pod can accurately transfer volumes anywhere from 0.5 microliters to 5,000 microliters. Controlling the incubation temperature and timing is crucial to achieve the color development in a timely manner. Manual ELISA includes moving the plate to and from incubators while making sure to preheat the incubator and time the incubation. Peltiers with plate-specific adapters on the BioMech ensure even temperature distribution between wells. Superior environmental control can be achieved by integrated incubators. The temperature and timing of these incubations are all controlled through the BioMech software. ELISA requires consistent pipetting so that you can avoid the technical variation and focus on the biological variation. However, when pipetting manually, it is impossible to pipette every sample the same way. By using automation, you can easily achieve consistency between samples and assay plates, as the BioMech treats them in a uniform manner. For high-throughput applications, SAMI EX Planning Scheduler creates an efficient, reliable schedule that executes the method as scheduled, consistently, each time the method is run. As with any other assay, ELISA is susceptible to contamination. Manual ELISAs require extensive planning and exhaustive cleaning. BioMech comes with an optional HEPA filter so that you can carry out the entire assay in a controlled environment. BioMech filtered tips minimize the carryover between samples and reagents. In addition, Span 8 liquid displacement pipetting enables flow-through washing of pipetting lines and fixed tips, providing you peace of mind. Want to improve your ELISA and accelerate your productivity? Contact Beckman Coulter to find out more about how BioMech can help you. Our consultative approach means that we work with you to find out an automation solution that works for you.